everyone, my name is Hadley and I'm a statistics tutor for the Academic Resource Center at Seton Hall University. In this video, I will be explaining the foundation of hypothesis testing, also known as significance testing, and how to conduct significance tests for means and proportions. To begin, hypotheses are predictions about the population, usually prediction that a parameter equals a certain value or is in a range of certain values within the population. A significance test uses data to summarize data about the hypothesis to determine if it is supported or not by the data. There are 5 orderly steps to properly conduct a significance test. These are 1. The statement of assumptions, 2. The statement of null and alternative hypotheses, 3. The calculation of the test statistic, 4. The calculation of the p-value, and 5. The conclusion of hypotheses based on the p-value. Let's start with the first step, the statement of assumptions. Depending on the data and hypothesis you are testing, assumptions may need to be made about the randomization of the sample size, and population distribution. To select an unbiased sample, we must assume that the data for the sample was selected completely randomly. For sample sizes under 30, we must assume that the data is normally distributed, as normal variables in a sample may not follow a normal distribution in a small sample, unlike a large population, due to the central limit theorem. This helps increase the validity of the hypothesis test you are conducting, so be sure to state your assumptions at the beginning of the significance test. Finally, it is crucial to state the level of significance. Depending on the question asked, the level of significance will usually be 90%, 95%, or 99%. The second step is to state the null and alternative hypotheses. We state 2 hypotheses so that we may reject one and fail to reject the other based on the data given by the sample. The null hypothesis, denoted as h sub 0, is the statement that a parameter equals a certain value. The alternative hypothesis, denoted as h sub a, is a statement that a parameter falls within a range of values. If you are conducting a two-tailed test, which is used to determine if a parameter differs from a certain value, then the alternative hypothesis is denoted with an inequality symbol. If you are conducting a one-tailed test, which is a test used to determine if a parameter is greater than or less than a certain value, the alternative hypothesis is denoted with a greater than symbol or a less than symbol, respectively. The certain value used as a comparison varies depending on what your question is asking. For significance tests for proportions, the value of comparison must be between 0 and 1. For significance tests for means, the value of comparison can be any number. Once this value is determined, the null and alternative hypotheses are written as such. h sub 0, the Greek letter mu, equals the value of comparison, or h sub a, the Greek letter mu, is unequal to, greater than, or less than the value of comparison. The third step of conducting a significance test is to calculate the test statistic value. The test statistic summarizes how far a point estimate falls away from the null hypothesis value. The formula for the test statistic for means is, spoken as, the mean of the sample minus the null hypothesis value divided by the standard error for means, which is a standard deviation divided by the square root of the number of observations. The formula for the test statistic for proportions is the mean proportion minus the null hypothesis value divided by the standard error for proportions, which is the square root of the null hypothesis value multiplied by 1 minus the null hypothesis value divided by the number of observations. The fourth step of the process is to calculate the p-value based on the test statistic. The p-value is the probability that the test statistic equals its observed value, or a value even more extreme is the direction given by the alternative hypothesis. Though the test statistic is used as a z-score or t-score, depending on the amount in your sample, for both tests, the p-value is calculated differently for two-tailed tests and one-tailed tests. For two-tailed tests, the p-value is calculated by adding the probability that a random value is greater than the absolute value of the test statistic, and the probability a random value is less than the negative version test statistic. In a normal distribution, the calculation for the p-value of a two-tailed test looks like this. For one-tailed tests, in which the hypothesized value is greater than the null hypothesis value, also known as a right-tailed test, the p-value is calculated by finding the probability that a random value will be higher than the test statistic. For one-tailed tests in which the hypothesized value is less than the null hypothesis value, also known as left-tailed test, the p-value is calculated by finding the probability that a random value will be less than the test statistic. Both are visualized in a normal distribution as such. The fifth and final step in conducting a significance test is to state your conclusion. To determine your conclusion, you will compare the level of significance. If it is 90%, your value will be 0.1. If it is 95%, your value will be 0.05. And if it is 99%, your value will be 0.01 with your p-value. If your p-value is greater than the level of significance, you will fail to reject your null hypothesis. If your p-value is less than the level of significance, you will reject your null hypothesis. Be sure to apply your conclusion to your hypothesis in a full sentence. I hope this video was helpful to you. If you would like further explanation, please stop by the Academic Resource Center to talk to a tutor. To learn more about other statistics topics or subjects that you may need assistance with, feel free to check out our other videos posted by our tutors.